experiment we will see about the verification of Kirchoff's law. So in Kirchoff's law you have KCL and KVL. KCL is nothing but Kirchoff's current law and KVL is Kirchoff's voltage law. So first let us see about the Kirchoff's current law. It is nothing but the algebraic sum of the currents meeting at a node or a junction is equal to 0. So now we will just analyze the circuit. So here you have a RPS and you have a current. Here as per this circuit the current I1 is entering, and if you could see I2 and I3 are leaving. So what does the statement states? The algebraic sum of the current entering should be equal to the sum of the current which is leaving the circuit. So I1 is the current which is entering. Now this I1 will be equal to I2 plus I3. So that is the logic. Now we will move on to the theoretical calculation, how it has to be carried out. So now you know the general equation, V is equal to I into R. Now here this is your variable power supply, RPS regulated power supply, where I can vary as per the readings. If I want to take 10 volts, 20 volts and 25 volts, accordingly I will vary my RPS. Now the current measurement, what are the current measurement I have to move? I have 3 ammeters, so I1, I2 and I3. So now I1 should be equal to I2 plus I3 as per the logic in the circuit. Now after that I am going to write my output. This theoretical calculation the student have to perform before entering the lab, and where they can check only with the practical values in the lab. So now we'll move on to the calculations. Now V is nothing but V is equal to IR. Now we'll just take each loop. Now if you take each loop, now this is having the voltage source as 20, the second loop does not have, so that is equal to, now what are the unknown components is nothing but we'll just take the current in the loop. It is not this capital I1 or I2, it is just the current in the first loop is taken as I1 and the current in the second loop is taken as I2. So now I1, I2 into R. Now we'll find out this R matrix. So now R matrix, this R1 corresponds to the resistance in the first matrix. Now here you have 330 ohms plus 1K. So which has been represented here as 1330 ohms. Now in the second circuit, what are the total resistance? That will be represented here. That is R22. That is nothing but 1K plus 1K plus 220. So you have 2220 ohms here. Now what is the resistance in between these two circuits? That is going to be represented as R12 or R21. That is, here the current is, we take the clockwise direction of the current in both the circuits. So in that case, if I am going to take the clockwise, here when I am going to take the clockwise, the current through the resistance will be in opposite direction. So I put a negative sign, and here the resistance is 1000, so 1000 ohms. Okay. So this R11 is the total resistance in the first circuit, R22 is the total resistance in the second circuit, and R12 or R21 is the negative of the resistance in the interconnecting path, provided the current direction through this resistance is opposite. Now you have calculated your del value. Now in order to find your current I1, we have to find your del 1. If I want to find my current I2, I have to find my del D2. Here nothing but in this delta circuit I am just replacing the first column by the voltage, then I will get my del 1. If I am going to replace the second column, minus 20 and 0 in this, from this del I will get del 2. Now you find out your currents accordingly. Now for this the value taken here is 20 volts. For this 20 volts it is 22.7. So we are getting the currents as 12 and 10.24. So we can take any one of the value and check your outputs. Now we will move on